AWS and Azure have some features that are very similar to each other, as well as some big differences. This set of videos is aimed at AWS professionals that are looking to transition to Azure or learn some Azure skills. I'm not going to spend a lot of time in AWS itself, but in the future I might produce some AWS specific videos for those people that work with Azure and want to learn AWS. The video today, we're going to be looking at a couple of the networking features in this part 1, and then part 2 will elaborate on those networking features, possibly tomorrow or the day after. We're going to start here in the AWS console. And one of the key features of AWS is AWS VPCs, or Virtual Private Clouds. Now, the AWS guys out there will know that in every AWS region, you have a default VPC, and this default VPC has one subnet per availability zone in that region. And that when we work with subnets in AWS, they're classed as either public or private subnets. And it all depends on whether the subnets are giving out public IP addresses and whether the subnets have gateways that allow them to connect out to the internet. So if we have a look at a couple of these things, so here in the portal, I'm in the London region right now, and I've got the London region default VPC, and you can see some of the details there. If we look down in subnets, I can see that for the London region, we have 2 availability zones, and the default VPC has 1 subnet in each availability zone. Now, if we take a look at one of these subnets, on the route table, we can see the standard routes for a subnet. We have the local route that allows traffic to flow between the different subnets in the VPC. And we also have this default route as well. Now, this default route is sending traffic that doesn't match the local subnet, the local address space, out through the internet gateway. So for VPCs in AWS, if you want traffic to flow towards the internet, then you need to create internet gateways. And we can see that here. There's the internet gateway, and this internet gateway is attached to the default VPC. And the route in the route table, we can see the route table for this VPC. There's the route table there. The route table basically said anything that doesn't match 172.31.00/16, anything that doesn't match that, send towards the internet gateway and off to the internet. Now, in order to send traffic to the internet, you can either use an internet gateway or you can use NAT gateways. And down here we can see NAT gateways. Now, there aren't any NAT gateways created for the default VPC. When would you use these? Well, internet gateways are used on public subnets. When the instance is deployed to the subnets when given public IP addresses, they can then use the gateway to communicate with the internet and receive traffic from it. NAT gateways, well, they're also deployed to public subnets, but they're useful if you've got subnets with instances that only have private IP addresses, and you want those private IP address machines to connect into as well. They can connect through NAT gateway. So in AWS, and again, your AWS professionals will know, we have the VPCs broken down into subnets. Those subnets then are either public or private. If they're public subnets, they're assigning public IP addresses to instances. And we can see that both of these are auto-assigning public IP addresses. They're auto-assigning public IP addresses to instances that can then use the internet gateway that's attached to that subnet to forward traffic towards the internet. In addition, we can create NAT gateways for private subnets. So to allow them to connect to the internet. So that's AWS and a few of its components that I'm sure you're all familiar with. So let's, for the AWS guys then, take a look at the Azure components that we configure to make up similar networks and settings. So let's flip to the Azure Console. So this is the Azure Console. When you sign up to Azure, you'll be on the dashboard initially. From the dashboard, we can navigate around the entire Azure sort of ecosystem. What we're interested in today is the virtual network components. So we don't create VPCs in Azure, we create virtual networks. And you'll notice here there's two types of virtual network listed: Virtual Networks Classic and Virtual Networks. Now in Azure today we still have two models that we can work with: the Classic or Service Management model, and the ARM or Azure Resource Management model, which is the current model. And we use Azure Resource Manager APIs, Azure Resource Manager features to construct our networks and Azure deployments in general today. AWS had a similar sort of components when AWS was first introduced. They had a classic model where you had very little control of the IP addressing scheme. This classic model was replaced with virtual private clouds. It's sort of similar here, although with virtual network classics in Azure, we still had a lot of control of IP allocation. If you are planning a deployment, an Azure deployment from scratch today, you would stay away from the classic features and just use the Azure Resource Manager features. Now, if I click on the virtual network section, we're going to see a couple of virtual networks listed. But these are virtual networks that I have created. By default in Azure, there's no concept of a default network created, unlike AWS where you have default VPCs. So no concept of a default network. We have two networks here, but I've created them for my different applications. So when you first sign up to an Azure account and get a subscription, this screen here would be empty. Now the other thing to be aware with Azure, a bit like AWS, is that we can arrange our different components into resource groups. So I have a set of resource groups, and I've created a resource group here called Our Resource Group that I'm going to be placing all the components in that we create over these next few videos. Just makes it easier for me to then locate components later on, delete them as necessary, and so on. So we'll start off by creating a virtual network. So from Add in our resource group, we can say Add, and you can see if you type in virtual network, or you see we've got a list of recently viewed items. So I can say new virtual network there, virtual network, and we provide again either ARM or Classic, Resource Manager or Classic. Configure Resource Manager unless you've got a real reason not to. And then we provide a few details. So we provide a name for our virtual network. So we'll call it Our Virtual Network. And we choose address space. Now this is very similar to creating a VPC, where you assign a VPC a name and then you assign an address space. So it's chosen the next available address space for my subscription. So I'll leave it at 10.200/24. In fact, we'll change that to /16. Let's see if it overlaps or anything that I've already got configured. Then we create a subnet. Now in AWS, you have the concept of availability zones. We don't have that concept in Azure. So in Azure, you have the region, that's it. So when we create this virtual network, we assign it to a region, and then each subnet exists inside the same region. So I'm going to create a subnet called subnet 1. Subnet 1, and we'll assign a 10.200/24 address range for that subnet. It's picked up my subscription, and it's picked up the resource group that it's going to be placed in, and then we choose a location, a region, for it to be assigned. So we've got a list of regions for Azure. We'll stick to West Europe for this one. And I say create. When we say create, the virtual network will be created in exactly the same way that a VPC gets created in AWS. There are differences though here. I mentioned the availability zones, but also, and you can see my deployment succeeded there. If I just go back to the AWS console for a second, this is our VPC. And when you create a VPC, you assign an address space. So in fact, let's just do that. Let's create a VPC, give it a name tag, our VPC, and we assign a CIDR block to it. like that. Choose tenancy option, but we assigned a 16 address space. Now that's a single CIDR block that was assigned there, and we can then take that CIDR block, and that'll appear there in a second. We'll see the CIDR block in a second. We can take that CIDR block and break it down into subnets. In Azure, once we've created a virtual network, and we'll look at the virtual network here. There's a virtual network. Once we've created a virtual network, we can then assign additional address spaces as well to it. So you got the address space section here. And that's the original address space. But I can also say if we want, and I can save that. Now in AWS, when we configure a VPC and then we create subnets, routing is configured in such a way, and we saw the routing table earlier on, routing is configured in such a way so traffic from those subnets can flow. Yeah? So instances deployed to each subnet, they can talk to each other, as long as the network access control lists and security groups allow it. Same sort of thing in Azure. Here I've got 2 address spaces now, and each address space can have multiple subnets. And VMs deployed then to those subnets can all talk to each other. Routing's allowed between them. So I can go down here, create subnets. I've got my first subnet, subnet 1. And I can create subnet 2. Like that, using the second address space that I've configured for the virtual network. And that'll just take a second to add there. And these 2 subnets, they will be able to communicate and route to each other. So virtual network created, with an additional address space and 2 subnets created. Now, if I was in AWS now, I have to think, are these going to be private subnets, public subnets? Well, we don't have that in Azure. If it's in AWS, I have to think, well, for a public subnet, the public subnet's going to use the internet gateway to get out. So then I've got to create the internet gateway. But we don't do that in Azure. In AWS, I might think, do we need a private subnet? In which case, do we need to deploy NAT gateway to get out to the internet? Well, we don't have to think about that in Azure. In fact, in Azure, this is it. We're done now. If I deploy a virtual machine subnet 1, it can be given a private IP address, or it can be given a private and public IP address. It doesn't matter. It will be able to access the internet. There is an internet gateway sat in the background, but you don't see them. You don't control them. There's NAT service sat in the background. You don't see it. You don't control it. So for subnet 1, for example, if I deploy a virtual machine there, and I give it a private, it'll pick up a private IP address automatically. If I give it a public IP address, I will be able to connect to it from the internet, and services and users on there will be able to connect out to the internet. If on subnet 2 I deploy virtual machines that just have private IP addresses, well, they will be able to connect to the internet as well. There's no need for a separate NAT service, no need for a NAT gateway. So in that instance, Azure wins a little bit because it's simpler. Now, we don't need those extra components configured. Some would argue, though, because AWS allows you to define those components, AWS gives you a finer level of control over those components and who can use them and when. And that is true. So swings and roundabouts here with these 2 features. So we've both got networking configured. We've got a VPC. We've got the VNet configured. I think that's it. That's it for now for part 1 of this video. In part 2, we'll delve into some more of these virtual networking components for AWS and Azure, look at some of the key differences, and look at some of the similarities. And hopefully after this second video, you'll be able to go away and deploy an Azure virtual network, deploy some virtual machines to it potentially, and play around. Thank you.